everyone, and welcome to The Explainer. Today, we are getting strictly technical because we're diving deep into the NCP-MCI 7.5 exam, specifically Objective 6.7, covering UEFI, Secure Boot, and vTPM. Now, as infrastructure admins, you know exactly how fast cyber threats are evolving. Malicious actors aren't just attacking the OS anymore. They're trying to move lower and lower into the boot stack. And honestly, traditional operating system level security, it simply isn't enough anymore. You need foundational protections built right into the virtual hardware itself. So our specific goal for this session is to completely master this objective so you can crush it on the exam. We're going to build a deep, working understanding of UEFI, Secure Boot, and Virtual Trusted Platform modules running right on the Acropolis hypervisor, or AHV. So grab your notes, get comfortable, and let's get into it. Okay, let's dive into this blueprint-driven agenda. First up, we'll talk about why VM security matters. Second, we'll do a walkthrough of the UEFI boot order. Third, a walkthrough for Secure Boot and vTPM. Fourth, we'll cover exam traps and edge cases. And finally, the key facts to memorize.
All right, Section 1, why VM security matters.
So why does VM security matter so much at this specific low-level layer? Well, the pre-operating system environment is incredibly vulnerable to attacks by malicious loaders. Think about it like the foundation of a house. If the foundation is compromised before the OS even starts up, literally everything built on top of it is at risk. To secure that foundation, we really need to understand our baseline, which is UEFI, or the Unified Extensible Firmware Interface. You can think of UEFI as the modern, high-tech replacement for the old legacy BIOS. Nutanix AHV fully supports starting guest VMs with UEFI firmware. And not only does it support larger hard drives and give you way faster boot times, but it is the absolute, non-negotiable, required foundation for all the advanced security features we're about to cover. Basically, without UEFI enabled on your VM, you simply cannot use Secure Boot or vTPM. It's the starting line for everything else. Building right on top of that UEFI foundation, we have the vTPM, or Virtual Trusted Platform module. AHV vTPM is essentially a software-based emulation of the TPM 2.0 specification. It works just like a virtual device that's attached to your VM to manage cryptographic keys and protect both hardware and software integrity. Virtualizing this hardware security chip is absolutely vital for a bunch of modern use cases. For instance, did you know that installing Windows 11 actually requires TPM 2.0 and Secure Boot to be enabled? It's also heavily utilized for Microsoft Windows Defender Credential Guard to isolate user credentials, and, crucially, it supports Windows BitLocker encryption. It's a real game changer for virtualized security. Moving right along to Section 2, walkthrough of the UEFI boot order. Managing how a VM boots is obviously a fundamental administrative task, right? But when you're dealing with UEFI on AHV, there are some very specific power state requirements depending entirely on the management tool you use. Currently, Nutanix does not support setting up the boot order for UEFI VMs using the Prism Central or Prism Element web consoles, so you basically have two options. Now, what's really interesting about this slide is the strict power requirements for each. Option 1 is the UEFI firmware menu, but you've got to ensure the VM is powered on to use this. Option 2 is the Acropolis command line interface, or aCLI, and for this one, you must ensure the VM is powered off before you try setting the boot device order. Mixing up these power states is a classic mistake, so definitely keep that straight for the exam. And get this, there is a very specific operational quirk you absolutely must understand regarding power cycles. Whenever a power cycle event occurs, the system automatically configures the Acropolis default boot device order. And guess what that does? It places the CD or DVD-ROM device first in the boot order. So why does this matter to us? Well, imagine you have an ISO currently inserted into that virtual CD drive. If that VM is power cycled, it's going to boot straight into that ISO instead of your OS. To mitigate this, administrators have to make sure they explicitly configure persistent boot order settings using aCLI after any power cycle event. Okay, let's move on to Section 3, walkthrough for Secure Boot and vTPM. Now that we've got a handle on how the VM boots, let's look at how we actually enforce authorized code execution and attach our virtual security hardware. Secure Boot uses policies embedded in the firmware, along with certificates, to act kind of like a bouncer at a club, ensuring that only properly signed and authenticated components are allowed to execute. But before you go and just flip a switch, you have to meet some pretty strict prerequisites. The Nutanix architecture has specific limitations you absolutely need to memorize.
First up, Secure Boot requires the Nutanix vrt.io package version 1.1.6 or later. Second, AHV does not support Secure Boot if the VM uses IDE disks. Third, Secure Boot VMs do not permit the hot plugging of network interface cards. No way around that one. And finally, you cannot directly enable Secure Boot on legacy BIOS VMs. You have to first change the VM's boot mode to UEFI. Seriously, missing even one of these requirements is going to cause your configuration to fail.
But once all your prerequisites are met, activation is incredibly straightforward. And this brilliantly illustrates just how simple it is. When you're creating a VM in Prism Central, right there under the Shield VM security settings, you'll find a simple checkbox to attach vTPM. As long as you've already selected UEFI as your boot configuration, simply checking this box, along with the Secure Boot box if you need it, securely attaches that emulated TPM 2.0 device directly to your new virtual machine. Easy as that. Now, for those of you who prefer getting your hands dirty in the command line, you can do all of this via aCLI. To create a brand new VM with these features, you use the vm.create command. But here's the kicker. You must explicitly define the machine type as Q35, followed by setting UEFI boot, secure boot, and virtual TPM all to true. If you're updating an existing VM that already meets all the UEFI requirements, you simply use the vm.update command, set the virtual TPM flag to true, and then hit it with a vm.on to start the VM. Also, here is a little golden nugget for the command line. If you create a VM using aCLI, you actually get the exclusive ability to find the location of the storage container for UEFI firmware and variables. That is something the Prism web consoles do not currently let you do. All right, Section 4, Exam Traps and Edge Cases. Okay, it is officially time to put on my exam coach hat. The NCFCM blueprint doesn't just test if you know how to turn a feature on. It really wants to see if you understand the hypervisor limitations and the potentially destructive edge cases of using those features. You need to pay very close attention to this warning, straight from the source material, regarding vTPM data loss. If you take a third-party backup of a vTPM-enabled guest VM, the vTPM data, which includes your crucial encryption keys, is completely unprotected. Why? Because the third-party backup software simply doesn't have access to that emulated hardware data. If you are using Windows BitLocker, those keys are critical. Restoring that VM from the third-party backup might render it completely unusable, resulting in literally unrecoverable data loss. Now, if the data isn't critical, say it's just being used for Windows Secure Boot, the backup software or user would manually need to attach a new vTPM device during the restore process. But with BitLocker, you're out of luck. Here is another classic exam trap regarding feature dependencies. So remember that UEFI is enabled by default when you enable Secure Boot, right? Well, if you later go back and disable the Secure Boot feature, it actually does not revert those underlying UEFI flags. The machine type will permanently remain Q35 unless you go out of your way to disable that flag explicitly. Do not fall into the trap of assuming that turning off Secure Boot just magically rolls the VM back to a legacy BIOS state, because it doesn't. Finally, you absolutely must know how these security features interact with disaster recovery, specifically cross-hypervisor disaster recovery, or CHDR. Enabling these advanced firmware protections will very often break cross-hypervisor mobility. For example, VMs with hardware virtualization and Secure Boot enabled, they cannot be recovered using CHDR. The exact same goes for VMs using Microsoft Windows Defender Credential Guard. It's just not going to work. Additionally, there's a specific OS limitation to be aware of. UEFI VMs running CentOS 7.4, CentOS 7.5, or Ubuntu 16.04 might actually fail to boot after a CHDR migration. Keep these limitations top of mind. So the crucial point is, you really need to know this stuff cold. Let's move to Section 5, Key Facts to Memorize. Understanding the operational boundaries is honestly just as important as knowing the setup steps themselves. To ensure your final memory retention before exam day, let's lock in these 4 non-negotiable facts. Number 1, defining the specific storage container location for UEFI firmware is an aCLI-only feature. The Prism UI will not do it. Number 2, Nutanix Virtual.io version 1.1.6 or later is an absolute unavoidable prerequisite for Secure Boot, right alongside avoiding IDE disks and avoiding NIC hot plugging. Number 3, third-party backups cannot access vTPM data, meaning restoring a BitLocker encrypted VM this way causes unrecoverable data loss. And number 4, setting the boot order requires the VM to be off if you're using aCLI, but it requires the VM to be on if you are using the UEFI firmware menu. And there you have it. You now have a complete, blueprint-accurate understanding of UEFI, Secure Boots, and vTPM for the AHV hypervisor. You understand the why, the command line execution, and most importantly,
the hidden traps that catch unprepared admins totally off guard. So, I'll leave you with this question to chew on as you continue studying. How are you going to integrate these strict, highly effective firmware-level VM protections into your own Nutanix infrastructure without breaking your existing backup and disaster recovery workflows? Think on that. Good luck on your NCP-MCI 7.5 exam, and keep learning.